Hello guys, my name is Michael Wilson, Chief Trainer for the Ghana Robotics Academy Foundation and also a Chief Technologist at the Council for Scientific and Industrial Research, Ghana. In our series of training sessions, I'll be introducing you to robotics, and my attempt will be to demystify the field of robotics and also try to practicalize your STEM education. I hope you enjoy the series of videos about to follow. In this introductory session, my main aim is to explain the field of robotics and demystify it. So let's ask ourselves, why did we get into the field of robotics? Human beings have always tried to have machines do work for them. In a way, we've tried to make our burden less lighter. To be able to achieve this, we need machines that are just like us, which means these machines should have our capabilities, should have our features, should be able to do the things we do, and on top of it all, should be able to think like the way we think. How are we able to do that? I'll start by identifying the human part that allow us to do the things that we do. So I'll say that human beings one key aspect of human beings are our senses. Human beings are equipped with senses. Our sense of sight, sense of touch, sense of smell, we are able to hear, we are able to feel. To be able to have machines that are like us, these machines should have these abilities. In robotics, we try to achieve this using sensors. Sensors, just like our senses, allow a machine or allow a robot to interact with its environment or to detect changes in its environment. Just like our eyes are used to see what is happening in our environment, our skin used to feel what is happening in our environment, our ears used to hear what is happening in our environment. Robots can be built with different kinds of sensors that allow them to detect different changes in their environment. So as human beings have senses, robots are equipped with sensors. I hope you have that. So now, humans have senses, robots are equipped with sensors, which means in building my robot, the first thing I have to identify is to identify which sensor will be able to detect the change that is required for my robot to perform the functionality for which I am building it. Let's make a simple one. So let's assume we want to have a robot that is able to detect the touch. Then we should identify the appropriate sensor. Let me pick some sensors. So these are examples of robot sensors from the EV3 setup. What I have here is an ultrasonic sensor. I have a touch sensor here, and then I have a gyro sensor. So in building a robot that can respond to a touch, I need to pick a touch sensor. Now, if I take the human senses do not operate on their own. Every sense that we have is connected to our brain through a nervous system, which means to build a robot, I need a nervous system, something that can carry the signals from this sensor to a brain of the robot. To do that, we have cables. Cables are able to carry electrical signals. So if I pick this cable and plug it behind this sensor, I have a mechanism to pick whatever the sensor detects and transmit it along this cable. But where does this cable end? Just like a human being, our nervous system or our nerves connect from senses to our brain, which means our robot should be equipped with a brain. How can we give the robot a brain? Let us do that by identifying the functionality of the human brain. In simple, I can say the human brain is an organ that accepts inputs from the human senses, processes these inputs, understands them, and sends out signals or information to other parts of the human body to respond to the input from the senses. That was simple to define. Now, can we think of any machine that has a similar definition? Your guess is as good as mine, a computer. A computer accepts inputs, processes the inputs, and then gives us outputs, which is information. So if I want to build a robot, then it feels best that this cable, which is serving as a nerve from the sensor, ends up on a computer. So the EV3 equipment or any other robot you want to build will come or will require that you have a computer. What I have here is called the intelligent brick. It is a mini computer running the Linux operating system, which means it is capable of accepting inputs, processing the input, and giving us information as output. So if I pick this setup that I have, a sensor with a cable as a nervous system, I can connect that to the brain or the computer of the robot, which means I have a sensor that can detect change in the environment, transmit the detected change to a brain to be processed. Now, the EV3 equipment comes with what we call ports. These are ports on the computer or the brain of the robot, to which nerve endings go. There are two kinds of ports. These ports numbered 1, 2, 3, and 4 are input ports and therefore accept connection from sensors. The other ports we have here labeled A, B, and C. I'll talk about them shortly. So now we have a partly built robot. After a human being's brain has processed what its senses are bringing to the brain, the human being's brain sends out output to moving parts of the human being. These moving parts allow us to perform actions. So if we want a robot to be able to perform actions, the robot must also be equipped with moving parts or parts that can perform actions. So far, we have the human being has a brain to which his senses connect to. And the computer has, the robot has a computer. In our case, the intelligent brick. For the EV3, to which sensors connect to. From the brain, signals generated from the processed inputs are carried out to moving parts, or let's say action parts of the human being, like our legs, our hands. So, a robot is also equipped with what we call actuators. The actuators allow a robot to perform actions. I'll pick an example. What we have here is a servo motor. The motor, when supplied with electricity, can turn. And as they turn, if there is any wheel or any object, it could be a knife, it could be a tool, a machining tool, it could be a drill connected to it, it turns along with it. So this can be used as an actuator to perform action when connected to the robot. So I could then say that this actuator, just like our legs, they are also connected to our brains through nerves. So again, I need another cable to serve as a nerve ending from the actuator. And where does it go? I told you I was going to explain the other port. The output ports of the robots, labeled A, B, C, and D on the EV3 robot. So what we have here is virtually a fully built robot that has the ability to detect change in its environment, transmit that change to a processing unit, a computer, and the computer able to process and transmit whatever signals to an action part or an actuator. But it's not done yet. Our robot hasn't got life. It's not alive. So what do? We need a source of power, source of energy. So energy, which is the ability to do it, has to be fed to the robot. Because these are electric or electronic devices, a battery can give life to our robots. So in this session, we have looked at how to build a full robot, equipped with 8 parts. Feel free to be creative. You can build a robot to look anyhow by your own design. The limit is your creativity. An example is what I have here, that has been built with sensors 2 live sensors, a grabber, 2 motors. Feel creative, create anything you want to. If you have any questions, you can leave them as comments. We will do well to address all your comments. In our following sessions, we will look at principles that allow us to make this robot perform specific actions. Thank you.